The question here says that which of the following function of time represents simple harmonic motion, periodic but not simple harmonic motion, and non-periodic motion. So we also need to give the period for each case of periodic motion. Here omega is a positive constant. So we know by definition that any simple harmonic motion can be written in the form of a cos omega t plus minus phi, where phi is the phase angle, initial phase angle, and or in the form of a sin omega t plus minus phi, where again phi is the initial phase angle. Now here whatever comes in the coefficient of variable t or time is termed as omega or the angular frequency, and we know that by equating this coefficient or the angular frequency by 2 pi by t, where t is the time period, we can find out the time period of the simple harmonic motion. So let us go with the options. So in the option 1 we have sin omega t minus cos omega t. Here using an identity, if we can transform this in the form of either a sin omega t or a cos omega t, then we can say that it is a simple harmonic motion. Else we can see that this is a periodic motion, because this is just addition of two periodic motions. So let us investigate it further. So we can use identity over here, and identity we can use over here is sin a minus sin b, and that is equals to 2 sin a minus b by 2 cos a plus b by 2. And using this identity we can write that equation in the form of root 2 sin omega t minus pi by 4. So we can see that this equation is in the form of a sin omega t minus phi, where a is root 2 or the amplitude is root 2, and here omega is omega, just so we can find out the time period using this formula. So time period would simply be equal to t equals to 2 pi by omega. So this the a part of this question is the simple harmonic motion, and its time period is 2 pi by omega. Now moving forward to the b section of this question, and b section says that it is b says that it is sine cube omega t. Now we can use a trigonometric identity to transform this into linear form. So sine cube omega t can be written as 3 sine omega t minus sine 3 omega t divided by 4. Now here we again see that this is an addition of two periodic functions, but this can't be written in the form of either a cos omega t or a sin omega t. So this can't be simple harmonic motion, but indeed this is a periodic motion. So with the different frequencies here, in the first part we have omega t, and in the second part we have 3 omega t. So we can say that collectively it will repeat with the largest time period. So here the second part has a higher frequency. We can find out the frequency using this technique that we talked about earlier, that whatever is in the coefficient of t variable, we can equate it to omega, and that omega is equals to 2 pi by t. We can write t equals to 2 pi by omega. So using the same technique we can figure out the time period for this part, and that would be equal to here the coefficient of variable t is 3 omega. So 3 omega will be equal to 2 pi by t. Now t would be, time period would be 2 pi by 3 omega. Similarly time period for this part would be omega would be equal to 2 pi by t. So t would be 2 pi by omega. Now we can see that this first part is 3 times that of the second part. So here the time period of the second part is much lower than the first part. So we can say that the addition of these two, the time period for the collective function here is, it would be equal to 2 pi by omega, because this is the larger time period for which the function is repeating. Now moving forward towards the third part, so here this part says that it is indeed a periodic function with the time period of 2 pi by omega, but it is not a simple harmonic function. So the third part of the question says that it is 3 cos pi by 4 minus 2 omega t. Here in third part we can easily see that this can be closely related to a cos omega t plus minus 5. Now here we have to find out omega as well. So this is a simple harmonic motion indeed, and we have to in order to find out the time period, we can relate the coefficient of time variable t with 2 pi by t. So let us go further. So in the C question we have 3 cos pi by 4 minus 2 omega t. Now in order to find out the time period, we need to take out the entire coefficient of time t. So it would be 2 omega would be equal to 2 pi by t, where t is the time period. So t would be equal to pi by omega. So the time period of this function would be pi by omega, and this is a simple harmonic function. So we can say that 3 cos pi by 4 minus 2 omega t represents a simple harmonic function, and its time period is pi by omega. Now moving forward towards the fourth question, we have cos omega t plus cos 3 omega t plus cos 5 omega t. So here again we see that this is an addition of 3 periodic functions. So indeed this is a periodic function, and the time period of this periodic function would be equal to the largest time period that this all would be having. So here omega would be equal to 2 pi by t, and here the omega would be equal to 3 omega would be equal to 2 pi by t, and in this part we have 5 omega would be equal to 2 pi by t. So here t would be equal to 2 pi by omega, and here t would be equal to 2 pi by omega, and here t would be equal to 2 pi by omega, 5 omega, here 3 omega would be equal to. Now we can see that when this part completes one cycle, the second part would complete 3 cycles, and the third part will complete 5 cycles. So collectively we can say that the time period for this collective function would be 2 pi by omega. Now this is not a simple harmonic motion, because this can't be represented in the form of a cos omega t or a sin omega t. Now in fifth part of the question, we see in the E part, we see that the function is exponent of minus omega square t square. So this is an exponential function which is not repeating at any time. So this can't be either periodic or a simple harmonic equation. So this is none of those. Now moving forward to the last part of the question, F. It says 1 plus omega t plus omega square t square. So this again is increasing function, which as t tends to infinity, it will tend to infinity and it will not repeat. So this can't be either periodic or simple harmonic function. Thank you.